Statistics Week 8, Part 2. We just introduced the concept of a confidence interval with the example supposing that for a previous iTunes example, we don't know the population mean mu, but we do know that the population standard deviation is sigma equals 1, and we've taken a sample size of 100 and gathered some data. From this, we were able to construct a confidence interval, in this case a 95% confidence interval that was between 1.8 and 2.2, that allowed us to say that the unknown population mean number of songs downloaded from iTunes per month is between 1.8 and 2.2. Continuing with this, we can say that the 95% confidence interval implies two possibilities. Either the interval 1.8 to 2.2 contains the true mean mu, or our sample produced an X-bar sample mean that is not within 0.2 units of the true mean mu. The second possibility happens for only 5% of all the samples. A confidence interval is created for an unknown population parameter, like the population mean mu or the standard deviation. Confidence intervals for some parameters have this form: point estimate minus margin of error, comma, point estimate plus margin of error, where the point estimate may be either the sample standard deviation, or in this case, the sample mean. The margin of error depends on the confidence level or percentage of confidence and the standard error of the mean. Here's an example. A survey of statistics class is made for the number of times each student eats out in a week. Assume that the standard deviation is known to be 3 meals. Construct an approximate 95% confidence interval for the true mean number of meals the student eats out each week. Suppose that the sample mean is 10 for 25 students surveyed. Let sigma equals 3, that was our 3 meals here, and n is 25, the 25 students surveyed. We construct the interval this way: x minus 2 times sigma over the square root of n. The sigma over the square root of n should be familiar from the work that we did in Chapter 7 with the central limit theorem, because what's going to happen is since we're looking at sample means, they will, in general, when we take a lot of them, emulate a normal distribution, whether or not the original data was normally distributed or not. We say that we are approximately 95% confident that the true mean number of meals that students eat out in a week is between 8.8 and 11.2. In this case, a calculation in the constructed interval would be 10, the sample mean, minus 2 times 3, the standard deviation of the population, divided by the square root of 25, and 10 plus 2 times 3 over the square root of 25. A confidence interval for a population mean with a known standard deviation is based on the fact that the sample means follow an approximate normal distribution. Okay. Calculating the confidence interval with mu unknown and sigma known. Hang on. We're finding the sample mean x bar, which is the point estimate of the population mean. We're going to find the margin of error, or EBM, which stands for error bound for the population mean. And we're going to compute the confidence interval estimate, which is point estimate minus the error bound, comma, point estimate plus the error bound, or in symbols, x bar minus EBM, comma, x bar plus EBM. Note, the margin of error, EBM, depends on what we call the confidence level, and that's something we have to calculate or look up in a table for a normal distribution. The confidence level is the percent of confidence intervals that contain the true population parameter when repeated samples are taken. Most often we choose a confidence level of 90% or higher. 95% will be fairly common in our work. We do this because we want to be reasonably certain of his or her conclusions. There is another probability called alpha, which is the probability that the interval does not contain the unknown population parameter. Mathematically, alpha plus CL equals 1. Here's an example. Suppose we have collected data from a sample. We know that the sample mean is, but we do not know the mean for the entire population. The sample mean in this case is 7, and the error bound for the mean is 2.5. X bar equals 7, and our error bound is 2.5. So the confidence interval will simply be 7 minus 2.5, comma 7 plus 2.5, which is a confidence interval of 4.5 to 9.5. If the confidence level CL is 95%, then we say that, quote, we estimate with 95% confidence that the true value of the population mean is between 4.5 and 9.5.